9.2, example 5. In this example, we're going to look at finding a third-order Taylor polynomial for f of x equals 2x cubed minus 3x squared plus 4x minus 5 at x equals 0 and at x equals 1. So here we go. So for part A, we're trying to find the third-order Taylor polynomial, which means we want a power of 3 when x equals 0. The polynomial that we're given is already written in powers of x when x equals 0, and it's of degree 3 because there's no parentheses x minus anything. So it is its own third-order Taylor polynomial at x equals 0. It's already done. The harder one is going to be b. So we can't just replace x with x minus 1 because that would shift the graph 1 to the right. Right? If we put an x minus 1 everywhere, that would mean it would shift the graph. What we have to do is come up with a new polynomial that you can put x minus 1 in there, and it remains the same exact polynomial. So let's recall the definition of a Taylor polynomial. When x equals a, it's f of a plus f prime of a times x minus a plus f double prime of a, x minus a squared all over 2 factorial, plus the third derivative of f at a times x minus a cubed all over 3 factorial, plus dot, 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 and you continue the pattern. So what I'm going to need is I'm going to need at least 3 derivatives and plug in 1. And I'm plugging this 1 into my original function of f of x. And if we recall, f of x was 2x cubed minus 3x squared plus 4x minus 5. So I'm going to go ahead and plug 1 in, and I get negative 2. I take the derivative and plug 1 in, and I'm going to get, and if I add all that up, I get 4. Take the next derivative and plug in 1, and I get 6. Take the next derivative and plug in 1, and I simply get 12. So these are all my coefficients. So all I have to do now is go ahead and write out my polynomial. So it's negative 2 over 0 factorial plus 4 times x minus 1 over 1 factorial plus 6x minus 1 squared over 2 factorial plus 12 x minus 1 cubed over 3 factorial. So I get negative 2 plus 4 times x minus 1 plus 3 times x minus 1 squared. And 3 factorial is 6, so 12 divided by 6 is 2. So what's cool is this is my third order polynomial. If I plug values into this function, they will give me the same outputs as my original function. So this equation and this equation around x equals 1 will give me the same output. So like 1.00001 or 0.999999 will give me the same exact values. And normally you would not do this for a regular polynomial, but it's the same idea for more complicated functions.